Hi guys, this is Shahab. I've been a software engineer for 20 years and I have decided to create a series of videos called Sirtapias, which is a Persian expression and it means to discuss a subject matter in details, from A to Z. In this series, I will talk about various topics from programming to software architecture and how I learned those topics. This is the very first episode of the first season, and this season is dedicated to Roslyn. I will share with you how I learned Roslyn and how you could leverage its capabilities to empower your tools, framework, and development team. So let's begin and dig into it. So we know that the compiler was a black box for us. And to this black box, we are giving some files as an input or source text as an input, and we expected that to emit an assembly at the end for us. So this would have been our assembly. And we had some source codes as the input of this compiler as .cs files or .vvip files, depending on which compiler you're using or which programming language you're using. There were several phases for this compiler. So we had the first phase was parser, and it was responsible to tokenize everything and create a syntax tree based on the grammar of the language. The next phase in here is declaration phase. And in declaration phase, it analyzes source and imported metadata to form named symbols. So declaration phase. The next phase is binder. It matches identifiers to in the source code to the symbols that it finds. So binder, and the last phase is IL emitter. I think I need some space in here, so the last phase is IL emitter, and they are acting as a pipeline. So the output of one phase is an input to the other phase. This was a black box for us, and that causes some problems. For example, the capabilities were just limited to whatever the compiler is providing for us. I, as a developer, cannot extend those capabilities. Tools providers also have some issues with extending those capabilities, so they have to come up with a compiler of their own that mimics the behavior of the actual compiler to be able to provide capabilities like code refactoring or suggesting some codes or warnings and these kind of capabilities, and to empower the developers basically. So if we consider this box in here, this has several components or several APIs in it for each phase of the compiler pipeline, and the whole thing together is called compiler API. So if I want to put a name here, it would be compiler API. It consists of syntax tree API, which gives us provides a syntax tree and gives us the capability to communicate with the parser phase. And then we have the symbol API. It exposes hierarchical symbol table, and then we have the binding and flow analysis API. This exposes the results of the compiler semantic analysis. And last but not least, we have the emitter API. So as we said, every API is for each phase of the compiler pipeline, and they are giving us the capability to fetch the information from these phases in the pipeline, and also to manipulate the data and change the data in those phases as the compilation is running. So giving us more flexibility to create our own tools based on the requirement of what we are creating. So now the tools providers could create, for example, something like a colorizer, right? Colorizer, or a formatter, or I don't know, or some capabilities that you might already know about it, like edit and continue. Edit and continue. Using the same APIs exposed by the compiler API. There's more flexibility. These kind of things are called language services. Language services. Alongside the compiler API, there is another API called Diagnostic API. Diagnostics API. The focus of Diagnostics API is to provide warnings, errors, code suggestions, examining code quality, and all those sort of things to do. Today, we want to create an application or write a program that gets a source text as an input, creates a syntax tree for it, compiles it, and then emits it as an assembly. So let's jump into the code and implement that. So here I have a console application, and what we want to do is we want to have a string which acts as a source code for our application. And here we would like write a simple classic hello world application system, and then we are having a namespace episode 1, it's fine, and then public static class program, and then in here we would have static void main, and obviously at the end we just want to console.writeLine hello Sirta, which means from garlic to onion. The first things we want to do is to create a syntax tree. So create a syntax tree, var syntax tree equals syntax factory dot our syntax tree, and we are passing this source code. Before we go further, I would like to tell you that here in my application, I already included a NuGet package called Microsoft.CodeAnalysis.C#, and this is necessary to be able to work with all those APIs we talked earlier about. And this syntax factory class resides in that NuGet package, and also in this namespace in here. The second step would be to create a compilation. And to create a compilation, we are using the C# compilation class, and it requires various parameters. The first thing is the assembly name. Here, let's say just episode 1. The other is the options that we could provide for the compiler. If we go back to our diagram, here we always we had before the something that we could provide an options to our compiler to tell the compiler more about what we want to do, and sometimes also control the behavior of the compiler. So we could also give it like options in here. Let's get back in here. Then in our case, we just want to say we want to have a console application. And last but not least is the syntax trees, which is a collection of the syntax trees that we have created, in this case for this application. Let's just use a collection expression here and pass it there. The next step is to emit the assembly. And to emit the assembly, we need to write it to a file, whether executable or DLR, or we could write it also in a memory stream. So let's create our memory stream here. ms equals new memory stream, and then let's emit that one to this ms. And it will give us like a result back, whether this is successful, whether this failed, and what kind, and this result object would hold some information about what's happening errors, warnings, whether even the compilation were successful or not. So let's examine that. Let's say result dot is success, and if it is successful, we want to later on we want to load the assembly and execute its entry point. But if it is a failure, we just want to print out the diagnostics. Every diagnostic that is returned has an object called severity. And if it is an error, then let's write it in red. And if it is warning, then let's write it in yellow. And then at the end, let's just reset the color of the console for now. Okay, let's consider that the compilation was successful. So what we want to do is we want to load our assembly from the memory now. So let's say assembly dot load, and this memory stream that get buffer, it returns the whole array representing this memory stream, and in this case it would be our episode 1 assembly. And then we want to invoke its entry point. So we want to go to the entry point. Here we want to look for public and static members. So in the second parameter, I'm just passing static and binding class public. And we need to pass an array to the main function in here. It expects like in a string array as arguments, but since I don't have anything, I'm just passing a null in here and we should be fine. So let's bring up the terminal. Let's clear stuff. Let's try .NET run. Okay, so we get some errors back and also warning, and what it says, and it says no value for runtime metadata version found, no assembly containing system.object was found, nor was a value for blah blah, and it also couldn't find system.object, system.string, nothing is found. So the issue is that we forgot to reference the assemblies that are required to compile this application. So we have a string in here, for example, we had the void in here, we need to know what does namespace, public class, all of these things mean, and also the console class. So I would say, the step 0, since we are all programmers, every number should start with 0, is to reference assemblies or required assemblies, right? Required assemblies. So the first one is mscorelib or corelib, and that is where the type object exists. The second one is the console, and that is where the console exists. And the last one is the system runtime, which I think this is not going to work. I'm gonna access that through app domain, that current domain that get assemblies, and let's make it full name dot contains system dot runtime. Okay, cool. So another parameter that we could pass to a compilation object when we are creating that is the references. And here it accepts an array of references, and we could add now a metadata reference to the assemblies that we have. So the first one is the corelib or corelib, let's call it corelib. And the next one is the one for the console. And the last one is the runtime. Okay, I think we have everything we need. Clear. .NET on. Let's run it again. Oh, so we created an application that accepts a source code or a source text as an input, compiles it, creates a syntax tree, compiles it, and writes it in somewhere. Also, to make sure that this was successfully created, we loaded the assembly and we run the application in here. I think that's enough for this episode. In the next episode, we will discover the syntax tree API and we will get more familiar with syntax tree and how we could manipulate and create syntax trees by using the compiler API classes and methods provided for us. Then enjoy coding and دمتون گرم.